did the derivative part, and as you are familiar with derivative, so first of all I did some the implications of the derivative. So using derivative we can find the maximas and minimas of certain quantity of any quantity, right? Like if this is the graph of something, like if this is the consumption, if I say that this is the consumption of electricity with respect to time, this is in the afternoon electricity is consumed more, right? And then in the morning it is consumed less, right? So these are minimum and maximum point. So by using derivative we can find maximas and minimas, right? So we can find that maximas minimas using second derivative test. How we will find? As this is the maxima and this is the minima. So if we say, first of all we will find the we have to find the critical numbers. How we will find critical numbers? We will take the derivative of the function and make it equal to 0, then at that value be the critical number, right? And in that critical number you will check the maximas and minima. How you will check? First of all you have to find the critical number by making taking derivative of the function and make it equal to 0, right? So at that, if you got 2, right, if like 2 is a critical number, then you will take second derivative and put 2 in that derivative. If that is greater than 0, then it will be minima, and that critical number there will be minima. And if double prime of 2 is less than 0, at that critical number there will be maxima. How? Like if we see the scenario of the maximum point, on the left side of this point the slope is increasing, so this is first derivative, right? And second derivative is decreasing. So if at critical number, this is a critical number 2 or something, any number, right? So at critical number if double derivative is less than 0, so this is the case, then that is the point of maxima. There is a maximum point at that critical number, right? And if at the critical number the double derivative is greater than 0, then that is the in that number, at that critical number there is a point of minimum. So we have done these things, and after that we also did the partial differentiation, right? Partial derivatives. So in partial derivative, if we are taking derivative with respect to x, we will keep y as a constant, right? Then then we did some basic things of the derivatives, right? Differentiation. So what is differentiation? The process of taking derivative of the function is called differentiation, and the process of taking integral of the some function is called integration, right? So derivative of constant is 0 and derivative of some variable with respect to same variable is 1, and then quotient rule of the derivative and product rule, right? And power rule and extended power rule of the derivative. Then some important derivatives: derivative of exponential, derivative of logarithmic function, derivative of natural log of u is what? That is a 1 over u, and to multiply it with derivative of u, right? And what is the derivative of e to the power u? Derivative of e to the power u is again e to the power u, and multiply it with derivative of u. Then derivative of inverse trigonometric functions. So these were the derivative of trigonometric functions, and these are the derivatives of inverse trigonometric function. Now we have started the integration part. So if you understood the derivative part well, it means that you have covered the 50% part of the integration, because integration is the inverse process of differentiation. Integration is the inverse process of differentiation, and integration is denoted by this sign, and this is the function, and with respect to some variable we will take its integration. Now as I told you, integration is the inverse process of differentiation. So if derivative of x is 1, then integral of 1 is x. If derivative of x square is 2x, then integration of x 2x is x square. If derivative of x square plus 2 is 2x, then integration of 2x is x square plus 2. Similarly, derivative of x square plus 3 is 2x, so integration of 2x is x square plus 3. It means that integration of 2x is x square plus 3 x square plus 2 plus x square plus 0. So, it means there will be any constant. So, integration of 2x will be x square plus c, any constant. So, as derivative of sin x is cos x, so integration of cos x will be sin x. As I told you that integration is the inverse process of differentiation. Integration means antiderivation. Similarly, derivative of cos is minus sin, so integral of sin is minus cos. Similarly, derivative of tangent x is secant square x, so integration of secant square x is tangent x, right? Similarly, derivative of cosecant x is minus cosecant into cotangent. So, integration of cosecant into cotangent is minus cosecant x. So, we have done the integration part of the trigonometric function. Now, let us extend it these integrations, right. So, we did this integration of cos u will be sin u, right, and in derivative case we are multiplying derivative of u. So, here what is the inverse process of multiplication? We will divide this derivative, right. So, integration of cos u is sin u divided by derivative of u, right. Similarly, integration of sin u is minus cos u divided by derivative of u. Similarly, integration of secant square u is tangent u divided by derivative of u. Like here, integration of cos u is equal to sin u, this 2x is considered as u, is equal to sin u divided by derivative of u, which is derivative of 2x is 2. Similarly, as derivative of e to the power u is e to the power u, and again multiply it with derivative of u. So, integration of e to the power u will be e to the power u divided by derivative of u, right, because integration is the inverse process of differentiation derivative. I hope you are understanding these things. So, like e to the integration of e to the power u will be e to the power u divided by derivative of u, like integration of e to the power 3x plus 1 dx will be again e to the power 3x plus 1 divided by derivative of 3x plus 1, that is 3 plus c, right. Similarly, as we did that derivative of a to the power u is a to the power u natural log of a, and derivative of u is multiplied. So, what will we do in integration? In integration of a to the power u is again a to the power u and divide by natural log of a and multiply it with derivative of u, right. So, integration is the inverse process of differentiation. So, when when we are multiply something in the differentiation, so in integration we will divide those things, right. Now, as I told you that before taking the integration or finding the integration of function, first of all you have to see that is the direct integration of the function exist or not, right. This is the first approach. If the direct integration exists, then you have to take it directly, right. Second, if the direct integration not exists, then you have to see that if we simplify the question and then we have to take the integration, right. So, that is the second case. In the third case, we have to see that if we are applying some rules, etc., we have to apply some rules of integration. Now, we have studied the power rule of integration, that x to the power n, integration of x to the power n is again x to the power n plus 1 divided by n plus 1, right. Similarly, if we extend this power rule, this this is a function having power on it, and derivative of this function is exists here, right. So, its integral will be what? We will increase the power, right, and we will divide it with the whole power, right. So, This is the power rule of integration. If there is a function having power on it and its derivative is exists present near this function, so its integration will be, we will increase the power and divide it with the whole power. Like here, this is a function, sin x is a function having power 2 on it, right? And its derivative is present here. So its integration will be what? We will increase the power on sine and divide it with the whole power plus c, right? So this is the power rule of the integration. Now in case of differentiation, in case of integration, when there is a sine or cos alone in integration, what will you do? And having even power on it, you will use half angle formulas. Like on sine square x, you will use 1 minus cos 2x divided by 2, and if this is cos square x, you will use 1 plus cos 2x by 2, right? Then you have to take integration. Now if the power of the sinusoid, power of sine is odd, what will you do? You will split this sine in two parts, sine square x dot sine x dx. Then we can write sine square x is 1 minus cos square x into sine x dx. Now there are two things. We after this we can solve this integration directly by multiplying these things, right? Sin x dx minus integration cos square x into sin x dx, right? And then taking its integration. So integral of cos x is minus sin x, and here we will use the power rule of the integration. So this is a function having power on it and its in derivative exists here. So what will be its integration? We will increase the whole power and divide by it by with the whole power, right? So when you are taking integration of sine or cos, what will you do? First of all, you have to see its power. If its power is even, then you will use these formulas and then take its integration. If this power is odd, then split and use power rule. Like here, I will split this and then I use the power rule here. So these were the basics of the integration. Now before solving the integration question, first we will see if the question is solvable directly or not, right? Like here we can solve this directly, right? The integration of x is x square by 2 and integration of e to the power 2x is e to the power 2x divided by derivative of 2x, that is 2, right? The second step is first simplify question and then solve the integration, right? Like this, a plus b whole square. First we can simplify it by using some formulas. So I expand the formula, then I took the integration, right? So when there is a question of integration, first you have to see that the direct integration exists or not, or it is solvable directly or not, right? If it is, then solve it. If it is not, then you have to think that is there any formula or something that we can simplify the question. So first you have to simplify the question and then take its integration. Now if these two are not working, right, then the third step is use any rule of the integration, right? You can use power rule or you can use integration by parts, etc. So this is the, like if this is the question, so first you have to see that the integration of this function is exist directly or not. So as we cannot solve it directly, so I have to, the second step is to if there is some simplification possible in it or not, David, right? So you have to simplify it, right? So I can simplify it by using formula a cube plus b cube. You must remember these formulas, right? So this is a cube plus b cube. So we will expand this formula as a plus b into a square plus b square plus ab, right? then these two are cross and then take its integration. So the first thing is the whenever you are solving the question of integration, first you have to see that it is soluble by using direct integration or not. Direct integration, right? The second thing is the what, first simplify the question and then take its integration. If these two are not possible, then the third step is use rules of integration. Rules of integration, right? So we did these things. Now there is another thing, uh, like if this is a function having power on it and its derivative exists here but 2 is missing, so we will multiply 2 and divide here 2. Now we can take its integration. This is a function having power on it and its derivative exists here, so we will increase its power and divide it by the whole power, right? Now we can solve this question by using another method that is called integration by substitution, because sometimes it is difficult for us to find that if its derivative exists here or not. Like if this is a function, right, 1 plus under root x, so we didn't know its derivative directly, so this is a function having power on it, right? So we will substitute this as a u and then you will find du, right? So we replace this whole integration with u, so this will be u cube and you have to write this as a in terms of du. So I substitute this as u and then take its differential, so that is 2 du is equal to 1 over under root x dx, right? So instead of this I will write 2 du and this is u cube. Now you will take 2 outside of integration and this is 2 u cube du. Now take its integration, this is u to the power 4 divided by 4 plus c, so this will be cross and then just put the value of u, so that is your answer. So we have done the integration topics little bit, right? So in next lecture I will use more rules of integration, because it's like the backbone of the engineering, right? So you must know the derivative and integration topics. Okay, see you in the next lecture. As this was just a revision lecture and you already did these things, so I quickly did these things, right? So don't worry about it. If you didn't understand something, then you can ask through WhatsApp, right? Thank you.